Okay, for example number 5, the displacement of an oscillating object as a function of time is shown here. So from the graph, we have to determine the followings: the amplitude, free period, and frequency. Lepas tu angular frequency, and then equation of displacement as a function of time, and lastly the equation of velocity and acceleration as a function of time. So this one is the question based on graph lah. That's why you have to be able to understand what does the graph what does the following graphs means yang given here lah. Okay, so this one is for displacement against time. So based on the graph, we can see that the amplitude is plus minus 15, temperature plus minus, just write 0.15 meter, and then the period is basically the time to complete one cycle, which is this part here. So that is berapa? 0.8 seconds. And then we also have to calculate the frequency, which is equal to 1 over the period, which gives us 1.25 hertz as the frequency. And then we have to find the angular frequency. Well, angular frequency is just 2 pi f, or you can also use omega 2 pi over t. Both will give you the same answer, which is equal to 2.5 pi radian per second. Okay, you can opt to write in decimal point, or you can also write in pi. It's just up to you lah. Okay, right, lepas tu we have to write down the equation of displacement as a function of time. We know that the general equation is a sine omega t. Why do I use sine? Because this is a sine graph. Sine graph, they akan starts at 0 lah. Okay, x and y, they akan equal to 0. X and y, which in this case y there is equal to the time lah. Okay, so kita just substitute lah. X 0.15 sine omega is the 2.5 pi t. Okay, this is not the end. You have to also write where x and y is not. X is in what? It is in centimeter. So kita tukar tadi in meter, and t is in second. Make sure you write meter as in meter instead of just m. And then this one also, I'm just too lazy to write the full word. Okay, lepas tu we have to write down also the equation of velocity and acceleration as a function of time, where v punya equation is the rate of change of displacement. So we are gonna differentiate this in terms of time, which will gives us the 0.15 sine 2.5 pi t, which will gives us the equation to be equal to 0.375 pi cos 2.5 pi t. Okay, so if you have problem with differentiation, just let me know, or just try to refresh it by reading your maths notes lah. So where v will be in meter per second, and t again is in seconds. Okay, right, so do the same thing for the acceleration, but this time it is the rate of change of velocity. Okay, so we will differentiate the equation of velocity in terms of time. Okay, in terms of time. So remember, if we are differentiating, we are just gonna bring forward the value di t ni, lepas tu differentiate cos dia ni. So differentiation of cos in terms of time here will gives us a negative sign value lah. 0.938 pi square sine 2.5 pi t. Sorry I squeezed it into this place, but hopefully you can understand what I'm trying to do here. Okay, so basically that is the solution for example number 5.